Conspiracy Catz, high school physics teacher, May 2019.
Now, firstly, the second law of thermodynamics does not in any way contradict us having an atmosphere next to the vacuum of space. What we've got to remember, which is where you're confused, Nathan, is the second law of thermodynamics is about the movement of energy and not the movement of matter.
Jeez, thank you. You'd fail 6th grade Intro to Physics. Number 1. You heard of Albert Einstein by chance? You know he has this famous equation comparing energy and matter? From theuniversetoday.com, as Einstein showed us, light and matter are just aspects of the same thing. Matter is just frozen light, and light is matter on the move. Albert Einstein's most famous equation says that energy and matter are two sides of the same coin. You said the second law only applies to the movement of energy and not matter. How can that be when they're the same coin? Pray tell. Number 2. From the entropy site.oxy.edu, in molecular thermodynamics, it is considering the change in a system or surroundings or their total for which there are fewer accessible microstates to one for which there is an increased number of accessible microstates. Question: are molecules matter? If you would have said water is made of boll weevil silicon salts, it would have been more coherent. And finally, as a capper for your own personal train wreck of a dumpster fire that exposes you as a Dunning-Kruger pretender clown royale with cheese, we have Professor George Porter, Nobel laureate, physics.
Now let us look at some examples of spontaneous changes and see how they are accounted for in terms of the second law of thermodynamics. We'll take the simplest first and look at changes where only the entropy changes. Now, one, perhaps the simplest of all of these, is the expansion of a gas into a vacuum. I have in one of these bulbs some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy concept, that would have been difficult to understand and difficult to account for.
Fatality.
Turn out the lights, the party's over. They say that all good things must end. Call it a night. The party